Welcome to another episode of Block Talk. I'm Chris, and today I'm going to walk you through an example of how to use the Ethereum Logic App connector to interact with a Cosmos database. Now, over the last couple of weeks, we've done several demos of how to use the Logic App connectors to do various things with databases. So you've seen some examples of how to interact with SQL Server databases, MySQL, PostgreSQL. Today's example, we're going to go a little bit deeper and spend more time with the Logic Apps themselves. The scenario that we're going to walk through, I think, is a great end-to-end scenario, marrying two, I think, very interesting use cases. We're going to talk a little bit about IoT and some IoT scenarios and how those are interacting with the blockchain. Specifically, we're going to walk through a cold chain scenario using the refrigerated transport contract that you have available for either Workbench or in the in the blockchain developer kit. We're going to walk through how to tie those two scenarios together. Let's go ahead and let's jump just a little bit into Cosmos and start looking at the data, and then I'll talk about how these are all connected together. So you see here on the screen my Cosmos DB instance, and on screen you see there's 10 records that have been sort of uploaded to this. Now, in the IoT space, or the IoT supply chain and cold chain scenario, you have a number of options of how you want to look at data. You can look at data in kind of a real-time basis. You can look at that telemetry stream as it's coming in, and that's a very common, very popular use case. But just as common and very popular is looking at data as it comes in over time. I think the supply chain, cold chain scenario is a great example of this. Oftentimes, you don't want to look at any instantaneous value from a sensor. You want to look at it over time. You want to see, was the smart contract I had against transporting of my ice cream, transporting of my pharmaceuticals, were the boundaries, the minimum and the maximum temperature, minimum, maximum humidity, vibration, any of those contractual barriers, boundaries, were those adhered to, and what was the average over that time? So in the example we're going to walk through today, rather than looking at real-time data coming in from IoT Hub, we're looking at snapshots of data over time. And you see here I have a number of snapshots. This is a good example of real data coming from IoT Hub, real demo data, meaning you have all of the normal decoration that IoT Hub puts on data coming in, and then you have what is effectively the telemetry stream underneath it, right? I have temperature in degrees C, I have relative humidity, I can have anything coming in this. And this really starts talking to some of the interesting parts of this scenario and why we're using Cosmos for this. Cosmos as a schemaless database is a great place to store this kind of data where the incoming telemetry isn't super well suited to a SQL type, MySQL type of database. The schema coming in changes quite often, isn't necessarily harmonized amongst my network. This is a great example of being able to support that, but supporting that at global scale and supporting that with really sort of fast queries and sort of great flexibility. And you see here these 10 records are really largely the same. The only thing that really changes is like the timestamp. So these did come in at different times. And you see on the screen below temperature and humidity sort of changing semi-randomly. So this is the incoming data, again, all stored in a data set. And now I want to query this data and I want to look at this data and start understanding it. Now, in this example, we've simplified this only to look at one particular thing. We're going to look at the temperature in degrees C, and we're going to do an average on this. Now, the way we've approached doing an average here is to use a SQL stored procedure. One of the great things about Cosmos DB and Azure is I have a lot of shortcuts to create very common tasks. Like, for example, I have this new stored procedure shortcut. When you press that button, you get 99% of the scaffolding that you see on screen here. The only thing we had to change for this demo, in fact, the only code we wrote for the entire example that we're walking through here, is to change the SQL query that was scaffolded out for us. I think the original query was select star from table, basically. You see here we're actually only selecting a certain value from that JSON store, and we're creating an average over those 10 records. You see here, just to give you the answer, our previous run as we were testing this says of those 10 records, your average temperature is about 2.8 degrees Celsius. So this is the back-end piece. This is the Cosmos piece. And again, this data would come from an IoT hub. This data would come from some sort of process that is getting data through your telemetry stream, aggregating it, storing it, and then you later on will go through and process this data and turn it into intelligence, turn it into action. So let's go ahead and do a little more digging in. Let's look at the Logic Apps themselves. Here on the Logic App, we'll go into the Logic App Designer. Let me scroll up just a little bit. You see here, looks like there's a lot of steps, but it's again, the beauty of Logic Apps is it's very sort of serialized process. Here, the very first process is, let's wait to trigger on an HTTP request. In the demo, this is just a simple HTTP request that we're sending from something like Postman or Fiddler. In real life, this will come from some other backend automated system, right? Maybe it's Event Grid and it's monitoring things being posted into your SQL database, etc. Once those things are getting, or your Azure, your Cosmos database, once those things are triggered, then we go through this Logic App. This Logic App is very straightforward. Right out of the store, we just fill in the data. We're monitoring our telemetry database, looking at this collection. And once we're kicking off, we actually then go off and execute this stored procedure. So we go through, we get the stored procedure, we run the stored procedure. And then the output of that, we do a little bit of parsing of the JSON so that only the value we're looking at is the average. We're creating a little bit of decoration for the contract itself, creating things like a timestamp. And then we're going in and executing the Ethereum Logic App connector. Now this connector here is going to take that information, take the average, take the timestamp, and execute the smart contract function. Now let me show you the contract function here in some detail. Here you see on Remix, I have a contract deployed. This is the contract we're going to be interacting with. It's again a simplified version of the refrigerated transport sample that we have for Workbench, for the rest of the development kit. We are posting this exact contract as part of this walkthrough, so don't worry about the changes. You can use this contract verbatim. It's in the walkthrough. And as I was mentioning earlier, we're going to execute or interact with this ingest telemetry function. This function takes in two parameters, temperature and timestamp. You saw how we were creating those earlier. And then based on those two parameters, it does something very, very simple. It just looks to make sure the incoming temperature is between the max and the min value. And if it is, everything is good. If it's not, we will send compliance status to false. Now, assuming everything is between the min and the max parameters, then the rest of this contract is just executed as sort of the normal business process. I may transfer an asset responsibility. For example, if I'm sending it with a shipper, I transfer it to the shipper. When it gets to the destination, and maybe I transfer it back to the recipient. When the entire smart contract is complete, then I go ahead and maybe complete this contract and close it out. So it's a super simple, very, I think, easy to follow process. You can see here various states. You can see I've already deployed it to Ethereum Ledger in Azure. So let's go back to our Logic App now. And let's actually go ahead and run this. So we're going to run through this process. And again, this process is kicked off by a HTTP request from, in my case, I'm using Fiddler. You can use anything you want. There's great examples of how to create these post requests online. Again, the code is in our repo, so you don't have to go dig through it. You can just find it. But let's just go ahead and execute this post request. And you can see this post request is super trivial. Let's go ahead and execute it. It takes a second or so to execute. It's done. Let's go through and see what just happened. So inside, we're going to go through and we're going to look at the results of what just happened here. Here you see I'm looking at my runs history for this Logic App. You see all the green checks are good things. When I hit that HTTP request, my stored procedure executed. If I click into that, you can see the output of my stored procedure was 2.8 degrees. You see here the parse JSON will parse that value and take just the 2.8 out. Timestamp, creation, etc. But let's go ahead and look at the smart contract execution. So I have that smart contract address. This is the address that I get back when I deploy the contract into my ledger. You see here a value, timestamp. We're normalizing to a base unit of 10 for further processing later, but this is that 2.8 that was put in there earlier. And then you see here the action of this logic app is to give me the transaction hash. And really what this tells me is that that information was added to the chain. It was mined. Here's the hash of where that data now really exists. The next part of that logic app is just for demo purposes to look and show what's going on right now in the contract. So you see at that address, I have things like sensor types, I have counterparties, I have my range, min and max, but I also have the timestamp I just put in, right? This is the current timestamp, and you see compliance status. The 2.8 or 28, so that it was normalized properly, is between the values that we stated were min and max, and it all worked great. So again, I think it's a super simple example that does a lot of what could be very difficult to program, very painful sometimes to program activities, and makes it very simple. This takes maybe 15 minutes to create the logic apps. You saw running it took me literally 30 seconds, but I think it shows a lot of the great power of logic apps for Azure, for Cosmos, for Ethereum, and how putting all those together creates some pretty compelling end-to-end demos. So anyway, so I hope you enjoyed this episode of Block Talk. Please follow us on Twitter at MSFT Blockchain, or please subscribe to us on YouTube. Thank you.